Our third lesson in the transformations unit deals with rotations or turns. Our essential question: how do I rotate a figure? So rotation is our very first vocabulary word for today, and you will need to make a note card. A rotation is a turn around a fixed point called the center of rotation. Most of the time we use the origin on the coordinate plane, although technically it could be any ordered pair on the coordinate plane. A figure rotates at a specific angle and in a specific direction. Now, when you did rotations in elementary and middle school, they were always 90-degree angles or increments of 90-degree angles. That can change, but we do tend to stick with the basics. Okay, a couple of keywords you need to remember. Clockwise is to the right. All right, if we think about a clock, 12, 3, 6, 9, clockwise is going to the right. And counterclockwise is to the left. Again, thinking about a clock, 12, 3, 6, 9. Counterclockwise goes left. If you are absolutely positive you know those two vocabulary words, you don't have to make note cards for them. If there is any doubt in your mind you are going to confuse clockwise and counterclockwise, I need you to make a note card. So what are the rules for rotating about the origin? Okay, 90 degrees counterclockwise, 90 degrees to the left, is the same as 270 degrees to the right. Okay. And the rule for this, our ordered pair gets switched and the first one becomes negated. Okay, for 180 degrees about the origin, and it doesn't matter with 180 degrees whether you go clockwise or counterclockwise, your ordered pair simply becomes negated. And for 270 degrees counterclockwise or 90 degrees clockwise, your ordered pair switches and the second one negates. Now, I like the rules. Some people prefer to play with it, and I am going to show you both ways. You can also use a lot of tools in order to help you with rotations, but here's why I like the rules. Let's look at the coordinate plane, right? In the first quadrant, your X and Y are both positive. In the third quadrant, your X and Y are both negative. Okay, now this is your rule for 180 degrees. In the second and the fourth quadrant, we have to switch them. Now let's stop and think about this for a minute. In the second quadrant, is it the X value or the Y value that would normally be negative? It's the X value or the first number in your ordered pair. In the fourth quadrant, which part of the ordered pair is negative? Is it the X value or the Y value? Well, it's the Y value or the second part of the ordered pair. So to me, the rules for rotation just follow the rules for integers in the coordinate plane. Okay, your positives and negatives match up, and all I have to remember is to switch the X and the Y values in the second and fourth quadrant. But I'm very rule oriented, and I know other people are very visually oriented. So we're going to look at this a couple different ways. All right, let's graph and label each pre-image and image under the given rotation. So we have triangle CDE with vertices C at 2, 7. D is at 6, 5, and E is at 4, 1. C, D, E. Every time you graph, you have to label those vertices. All right, we're going 90 degrees counterclockwise. I always draw my little arrow to help me remember. Okay, so C is going to turn down 1 turn, right? So I'm going to come down so that I'm 7 across and only 2 up. E, I find really easy. That is 4 across and 1 up now. E prime, we're going to make that 1 and then up 4. And then D is 6 across and 5 up. So 5 across and 6 up. And I have rotated that 90 degrees. I did that visually. I did that by thinking about how it looks when I turn it on its side. If I do that using the rule, right, the rule says I take my ordered pair, I'm going to switch them, and in the second quadrant, the first number is negative. So negative 7, 2, yep, that matches what I graphed. Negative 5, 6, that matches what I graphed. Negative 1, 4, that matches what I graphed. Okay, I want you to pause the video and try number 2. You can do it visually or by reasoning it out, or you can use the rule. That's up to you. Okay, stop for a minute and check your work. I labeled mine incorrectly as I'm pausing for a minute to look at mine. Right, this was A prime, and this was B prime. Very important that your labels are accurate. This is 180 degrees, so I should be able to go diagonally to the other quadrant, right? A was in the fourth quadrant, A prime should be in the second. B was in the third, or first, B prime should be in the third. And that's how I noticed my mistake. The labels matter, and you have to be careful. All right, this time we're going 90 degrees clockwise. Remember, 90 degrees clockwise is the same as 270 degrees counterclockwise. Okay, you can use the rule or you can do it visually. Pause your video and try. Okay, take a minute and check your work. Make sure you graphed it correctly. And your ordered pairs are correct. All right, this one asks us for a trapezoid, just getting a few more points in. Again, pause and try it on your own. All right, take a minute, check your work. How did you do? Now, sometimes students ask me, all right, I just can't memorize those rules. What can I do? So let's look at a graph and let's look at 2, 1. If I rotate that 90 degrees and I'm going to the left, it's going to stand up here, A to A prime. And so you can you can develop the rule yourself, right? 2, 1 becomes -1, 2. So what happened? I switched them and I made the first one negative. Then you can rotate another 90 degrees and figure out what happens, and another 90 degrees. If you're really, really stuck and struggling with this, ask us for some patty paper, and we'll show you how to use that in order to make rotations a little more clear. All right, this is one of my favorites because it's not something you did in middle school, and it's really something we have to stop and think about. So our first question is asking us to rotate about point P. So I'm going to highlight that, just keep it in the forefront of my brain what I'm trying to do. And I'm going 90 degrees of segment AB about point P. Okay. Each point has to be rotated separately. Whenever you have one of these odd figures, you never rotate entire triangles or entire segments. You go point by point in order to figure it out. All right, so we're going to start up here at A, and I want to go 90 degrees. Well, let's see. I've got 1, 2, 3, 4, 5, 6, 7, 8 sections around point P. So if I do 360 divided by 8, I get 45. Each of these is 45 degrees all the way around, and that's helpful as I start rotating by different angles. Again, I took 360 degrees for a circle, and I divided by my number of sections to get that 45 degrees. All right, so A, if I rotate, I'm going clockwise, so I'm going to the right. If I come down to B, that's 45 degrees. C would be 90. Now let's look at point B. I come to the right. C is 45 degrees. D would be 90. Don't forget the bar because we rotated a segment. Let's look at a 180 degrees counterclockwise rotation of EF about P. So here's E, because I'm going to go one point at a time. I'm going to go counterclockwise, which means I'm going to the left. 45 is D, 90 is C, 135 is B, 180 is A. Okay, let's go to F. 45 would be E, 90 would be D, 135 would be C, 180 would be B. Don't forget the bar because we rotated a line segment. Now we're going to rotate a triangle. So our answer has to be a triangle. I'm going to put the little baby triangle symbol there to start. We're going 180 degrees clockwise to the right. Let's start with point D. I'm going right. Let's see. 45 is E, 90 is F, 135 is G, 180 is H. P. P is the point of rotation, so that doesn't change at all. Now E. 45 is F, 90 is G, 135 is H, 180 is A. So it becomes triangle HPA. All right, a 45 degrees counterclockwise, going to the left, of triangle, so triangle is going to be my answer, HPA about P. So H, I'm going 45 to the left, that becomes G. P is my angle of rotation, that's going to stay the same. A, 45 to the left becomes H. Ooh, reflect. We haven't talked about reflections in a little while here. We're going to reflect all of these in line HD. So I am going to highlight HD, just to keep that at the front of my brain. Now remember, reflections from our very first lesson have to be perpendicular to that line. Okay, so we have to be perpendicular to that line. All right, we want to reflect A in D, in HD. And if I come perpendicular, ooh, I'm at point G. All right, now I want to reflect BC. Again, you have to do each of these individually. So here's B. If I come perpendicular to HD, I'm at F. Let me write that down. Now I want to do D. Right? Sorry, C. And I want to go perpendicular to HD. Ooh, I'm at E. Okay, interesting. Notice it's not what we would consider straight across. I did not go C to F. Staying perpendicular to line HD as I do this. ED. All right, E. Where's E? E's right here. Perpendicular will be C. D is on the line of reflection, so D is not going to move at all. This is going to become CD. Triangle GPF. Well, I'm going to have a triangle in my answer. G. Where's G? Okay, let's see. I need another color. Let's do, I guess, green. G, perpendicular across that, becomes A. Let me write that down. P. P is on the line of reflection, so it doesn't move at all. And then F. F, perpendicular to HD, becomes B. And last but not least, triangle BPC. So triangle is going to be my answer. B. B, I've got a nice green line already showing me. That becomes F. P is on the line of reflection, so it's not going to change. C, I've got a nice green line showing me. That becomes E. Point by point when you have these strange figures. Do not try to do it all at once. You will mess it up. All right, take a minute to write a summary on rotations.